Alright, this is the third video where we're looking at this handout on synthesizing ionic compounds. So this time we're going to look at sodium chloride. Now the difference about this particular part of the handout is everything is blank. In the first example, I gave you both the diagrams and the text. In the second example, the diagrams are there to kind of give you some help. Then you had to fill in the text, and here you had to fill everything in. So let's just go through it, and please follow along. So sodium is described as having one valence electron weakly held far from a core charge of +1. So you can see that right here. One valence electron, core charge of +1. Again, sodium is in group 1, 1A, so that's where we get that information. How do we know it's weakly held? Again, because sodium is on the left-hand side, it's a very large atom and has such a small core charge. It's poorly, electronegative. Again, electronegativity is going to increase up and to the right on the periodic table. So sodium is going to be poorly electronegative. It's not going to hold on to its electrons very well. Chlorine, though, has 7 valence electrons strongly held close to a core charge of +7. So you can see here 7 valence electrons for chlorine and 1 empty spot and a core charge of +7. Chlorine is over here in group 7A. There it is. So that's where we get that information. Again, it's strongly held because chlorine, being on the right-hand side, is strongly electronegative. Being a small atom, having a large core charge of +7 makes it really strong, really good at stealing electrons. You can see that right here by this arrow. This 1 electron of sodium is being stolen by chlorine. And so in the description underneath that, you can see sodium's valence electron is more attracted to chlorine's core charge. Chlorine is just more electronegative. It's a smaller atom, has a greater core charge. It's more electronegative. It's going to pull on electrons more strongly. So this 1 valence electron by sodium is going to be stolen. Chlorine ends up with a +1 charge because now it has 1 less electron. Chlorine ends up with a -1 charge and a full valence shell here. Again, it gained that 1 electron. So sodium becomes a cation, chlorine becomes an anion, and they're going to be attracted to one another in a crystal lattice. So I didn't complete this part of the diagram, but basically when we scroll up to the top here, your diagram and description is going to look just like this, except it's going to be sodium and chlorine ions that are going to form the crystal lattice instead of potassium and bromine in the first example. But it's essentially going to be the same result. We're going to get that crystal lattice being formed. Okay? So hopefully this helps, and take care.